going the same direction. Our lead coefficient has to be negative. I don't know what negative number, but I know it's negative because the end of it is going down towards negative infinity. So this end over here, this right here tells me that it's a negative lead coefficient. Our number of real zeros are how many times we're crossing the x-axis. And we're never actually crossing the x-axis in this polynomial, so we have no real zeros. In the next example, I'm doing the same thing. So first I'm going to start talking about the end behaviors. So as x approaches negative infinity, meaning as we move to the left, that's an ugly infinity, there you go. Y is approaching negative infinity as well. As we move to the left, our graph is also moving downward. As x approaches positive infinity, so as x moves to the right, y is also approaching positive infinity. So as we move to the right, our graph is going upward. This has to be an odd degreed polynomial. And the reason why is because the beginning and end are going opposite directions. Our lead coefficient has to be positive. And the reason why is because the end behavior is going up towards positive infinity, which means it has to be a positive lead coefficient. And our number of real zeros is 1. We only cross the x-axis in one place. Moving on, for this graph we're determining whether it's an odd or an even degree, stating the number of real zeros. We're also going to talk about the lead coefficient and the end behaviors. So this graph has to be an even degreed polynomial. And the reason why is because it begins and ends going the same direction. So it has to be even degreed. We're crossing the x-axis in two places. We're crossing here and here, so we have 2 real zeros. So this is answer choice B for sure. But let's write out our end behaviors. So as x approaches negative infinity, so as we're moving to the left, y is approaching positive infinity. As we move to the left, our graph is moving upward. As x approaches positive infinity, so as we move to the right, y is also approaching positive infinity, so it's going up as we move to the right as well. And we know that our lead coefficient has to be positive because the right side of the graph is going up towards positive infinity here. And one more example of this. Same drill, so we're going to talk about the degrees and the real zeros, the lead coefficients, and the end behaviors. So this has to be an odd degreed polynomial because the beginning and the end are going opposite directions. So I know it's odd. I'm crossing the x-axis in 3 places. 1, 2, 3. So I have 3 real zeros. So it's answer choice C. But let's write out our end behaviors. So as x approaches negative infinity, it's moving downward, so y is also approaching negative infinity. As x approaches positive infinity, we're moving upward, so y is also approaching positive infinity. And our lead coefficient we know has to be positive, because the right side of the graph, as x is approaching positive infinity, y is approaching positive infinity. So it has to be a positive lead coefficient. And that is it for our polynomial functions notes.